When you think about it, what really makes something valuable? We usually think, okay, treasure is something rare, right? Gold, diamonds, that kind of stuff. And trash? Well, that's just junk. Stuff we throw out. But what if that line between trash and treasure isn't fixed? What if it's always moving, and we're the ones redrawing it with our technology? That's what we're diving in today, how new tech is forcing us to look at our own waste and even our own history in a totally new way.
Okay, so let's get right to the big question for this whole explainer. Who actually decides what's junk and what's a jackpot? Is it just about how much of something exists in nature, or is it our technology at any given moment that actually gives a material its worth? The answer, as you're about to see, is a game changer with massive consequences for our economy and our past. The key idea we're going to keep coming back to is this thing called a technogenic pivot. It's that light bulb moment in history, that click, when some new invention makes everybody look at a pile of what they thought was garbage and suddenly realize, wait a minute, that's a gold mine. We are going to look at 4 absolutely incredible stories where yesterday's trash became tomorrow's treasure.
First, we're going to talk about a type of steel that we literally can never make again. Then we'll get into a radioactive material that people once used for dinner plates. Yeah, really. We'll look at the cursed sand that drove gold miners crazy and the wild story of the world's very first plastic. And then we'll wrap it all up by asking, what priceless resource are we throwing in the garbage right now?
So let's start with the unbelievable story of low background steel. This is a story about how one single day, one explosion, permanently changed one of our most basic industrial materials, and why today we have to go treasure hunting at the bottom of the ocean to find the pure stuff.
The date you need to remember is July 16th, 1945. That's the day of the Trinity test, the first atomic bomb detonation. In that flash of light, we didn't just stumble into the nuclear age, we fundamentally changed the air on planet Earth. See, before that moment, all steel was silent, meaning it had zero artificial radioactivity. But after that moment, every single piece of steel made anywhere on the planet has been contaminated with a faint but permanent radioactive signature.
So how in the world does that happen? Well, a common way to make steel, the Bessemer process, works by blasting enormous amounts of air into molten iron. But since 1945, that air has been filled with tiny radioactive particles from nuclear tests, especially an isotope called cobalt-60. Those particles get sucked in and literally baked right into the steel's molecular structure. They become a part of it forever.
Which means, if you need perfectly clean steel today, steel without that radioactive background noise, you can't make it. It's impossible. You have to find it. And the only place to get large quantities of it is from ships built before 1945. We're talking about sunken warships from World War I and II, which have been sitting at the bottom of the ocean, shielded by all that water from decades of atmospheric fallout. Companies are literally raising old battleships from the dead just to get their steel.
And why go to all that trouble? Because this low background steel is absolutely essential for building our most sensitive scientific instruments. We're talking about medical scanners that need to detect the tiniest traces of radiation in a patient, or giant particle physics experiments trying to find dark matter. Even space probes like Voyager 1 needed it. Think about it. If your spaceship is even a tiny bit radioactive, how can it get an accurate reading of radiation out in deep space? It can't.
This brings us to our next case, and it's a wild one. Uranium. Today, this is a material that starts wars. Countries face sanctions over it. But back in the 19th century, it was just a really cool way to make your glassware glow in the dark.
Back in the 1830s, glassmakers in Bohemia found out that if they took a worthless byproduct from the local silver mines, this stuff called uranium, and mixed it into their glass, it created this absolutely beautiful, vibrant yellow-green color. They called it Vaseline glass, and it was a huge hit. But the real party trick was that under a UV light, it would fluoresce with this incredible, otherworldly green glow.
You have to understand, for the Victorian aristocracy, this wasn't scary, it was pure magic. People were filling their dining rooms with glowing green goblets and vases. They saw it as the ultimate symbol of progress, of humanity harnessing the mysterious forces of nature for decoration, with absolutely no clue what they were really holding in their hands.
And then the technogenic pivot happened. And for uranium, it was fast and hard. In 1942, right in the middle of World War II, the US government came in and confiscated all known uranium supplies for the Manhattan Project. In the blink of an eye, the value of this element was completely redefined. The cheap coloring for a fruit bowl became the fuel for the most powerful weapon on Earth.
All right, for our third story, let's head to the gold rush of the 1890s, where thousands of prospectors were, and I'm not kidding, throwing away a fortune that was way bigger than all the gold they were looking for. They just didn't know it yet.
So, when these guys were panning for gold, their equipment kept getting clogged up with this heavy, annoying black sand. They hated this stuff, they cursed it, and they just dumped it by the ton in giant waste piles. What they had no way of knowing was that this useless sand was actually loaded with platinum, palladium, and a whole bunch of rare earth metals like neodymium and dysprosium, the very things we need today to make everything from catalytic converters and electric car motors to the batteries in our phones.
So what's happening now? You guessed it, a second gold rush. High-tech companies are going back and buying up all those old abandoned mining lands, not for the leftover gold, but for the trash heaps. They are literally remining the toxic waste, using modern technology to pull out all those critical minerals that the original miners didn't even have names for. Okay, for our last trip back in time, let's talk about the weird journey of the world's very first synthetic plastic. A material that was invented to be a cheap copy of other things, but has now become a valuable luxury original.
So, bakelite was invented in 1907, and they called it the material of 1,000 uses. The whole point of it was to be a cheap and durable replacement for expensive natural things like ivory, jade, or tortoiseshell. It was for everybody. But now, in a world where we're literally drowning in cheap disposable plastic, original bakelite has become this rare collectible antique. Its unique look and feel just can't be copied by modern plastics, so original jewelry and radios from the 1930s now sell for thousands of dollars. It's the ultimate paradox. So you see the pattern here, right? In every single one of these stories, a technogenic pivot happens, and suddenly what was worthless becomes priceless. And that brings us to the biggest question of all. What are we throwing away right now that our grandkids will see as a treasure?
Let's just look at the raw numbers for a second. According to geologists, we have about 19 years worth of mineable gold left in the ground.
And what about copper, the metal we need for, electrifying everything? Just 39 years. The era of just digging this stuff up easily is coming to an end, and fast. So where are we going to get these materials? We're going to get them from the mines we are creating every single day. The gold mines of the future aren't holes in the ground, there are landfills. We're talking about urban mining, pulling gold and silver out of our old electronics. Red mud, that toxic sludge you get from making aluminum, is now being called red gold because it's so full of rare earth elements. Even the ash from coal power plants is a concentrated source of critical minerals. Which leaves us with one final big thought to chew on. If our ancestors, using the best tech they had, tossed out platinum like it was dirt and made dinner plates from what we now know is weapons-grade material, what are we doing right now? What giant mountains of trash that we're creating every single day will be the most valuable, most sought-after resource on the planet in the year 2100? It's something to think about, isn't it?